Right, welcome. Well, hello, hello there. Okay, well, you know that we like to start with a bit of fun. So we're doing geometric series. In other words, series, we're adding up the terms. And the derivation I'm going to run through like beyond too quickly. Because you need to understand how the derivation works. Read through the textbook to see it. And let's get into it to see. So we know that if we're summing up a geometric sequence, then we're gonna go, well, we're gonna take the first term, we're gonna add the second term, we're gonna add the third term, we're gonna add, and so it goes until we add ARN minus 1, the last term. Right, we know that the first term's A and we're multiplying by R every time. Now, no funny stories this time. Let's see what happens if we multiplied this whole thing by R. So A times R is AR. Now I'm not going to write it directly below, I'm going to write it over here. AR times R is AR squared plus blah blah blah. AR to the n minus 2 is AR to the n minus 1 plus this one, if we multiplied by R, would be AR to the n. Okay, I'm going to hit a pause so you can look at it if you need to. Okay, so we're back. And let's see what happens. We're going to do some sneakiness here as well and say we're going to take the top one minus the bottom one. So Sn minus Rsn. So Sn minus Rsn. So this thing minus this thing. Well, we're going to take this and subtract this. Well, A minus nothing gives us A, right? AR minus AR. It's like they kind of cancel. We get 0. Plus, 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 plus. Well, that's going to cancel, and we got minus AR to the n. Okay, so in other words, Sn minus Rsn equals A minus AR to the n. Hey, look, common factor on the left-hand side. Just screams out to be factorized, doesn't it? Well, let's just keep us all awake now. So we're going to take out an Sn and go 1 minus R on the right-hand side. I guess we could take out an A if we wanted to. So A 1 minus R to the n. But we wanted Sn. So let's take this side and divide it by 1 minus R so that we can cancel it and just have Sn. What we do on one side, we do on the other. So Sn equals, wait, we need to divide this by 1 minus R. Well, there it is. Sn equals A 1 minus R to the n over 1 minus R. That was like the quick way of doing it. So I'm going to hit a pause and move my big head out the way so you can look at that beautiful formula, get rid of all that stuff, rewind if you want to see. In fact, no. Changing my mind. There it is. Scroll up. There's the formula. Enjoy looking at it, pause. And we're back to using the formula. So there's our formula. Now, all we need to know is how to use it. It's given to you on the formula sheet. Derivation is fascinating, but let's use it. So, example 1. Let's slow things down a bit. We have a geometric progression. So it's got a constant ratio with 7 terms. Here are the first 3 terms. Determine the sum. So determine the series. So what's 3 plus 15 plus 75 plus whatever that is times 5 plus plus plus. Okay, so let's look at a few things. A, first term is what? Well, it's 3. What's our common ratio and how do we work it out? Well, our common ratio is what are we multiplying 3 by to get to 15? Well, we're multiplying it by 5 because 15 divided by 3. So 15 over 3 gives us 5. Useful to show that working out. And the same thing here, right? Do we multiply by 5 here? Yeah, 75 over 15. Cool. Okay. Sn equals, what is that formula again? A 1 minus R to the n over 1 minus R. Okay, so we're saying A 1 minus R to the n over 1 minus R. We know what A is, we know what R is, we know what n is. Plug and chuck. S7 equals A 3 1 minus r. Well, we said r was 5 to the n, 7 over 1 minus, what is our ratio again? Well, our ratio, I think we said was 5, wasn't it? Okay, well, that's cool. We're just gonna put that into our calculator, which we have here. Oh, there it is. Love it. It's in the way. Look, I get to move it out the way easily nowadays. So we're gonna put it in there, and we're gonna say we've got a fraction 3 1 minus 5 to the 7. Nope. Right. Bracket 1 minus 5. That's a big number. 58,000. Oh, 58,593. So just to recap quickly. We worked out A and R because we need that in our formula. New formula to us for now. Sn equals A 1 minus R to the n over 1 minus R. And then we just plug in all the stuff that we need. N is 7. So we put in when we saw an n. Okay, you get the point. We subbed in the values, right? Okay, let's run through another couple of examples. And wait a second. This calculator is now in the way. Let's put it back up there. Move it out the way. Right, so we plugged in the values. Okay, let's go down. Example 2. 5 plus 10 plus 20 plus plus plus. Sn equals A 1 minus R to the n 1 minus R. Bits of that we need to work out. What are the variables that we should have? Well, we should have n, we should have a, we should have r, and we should have, well, we had n already. Well, let's see. A, that was easy. What's a? 5, right? There it is, first term. What's our constant ratio? Well, clearly we're multiplying by 2 here, because we went 10 over 5 gives us 2. Okay, n equals, no, we're not given n. Like, we know that that's the last term. Now, we've done this a few times where we've been given the last term and we need to determine what n is. So how are we going to work it out? Well, we know that Tn equals, what is it? AR to the n minus 1. This is our last term. So we know that 6, 5, 5, 3, 6, come on, 360 equals A. Well, we know A, we know R times 2 to the n minus 1. One equation, one variable, solve. Go for it. Are you happy to solve that? Cool. I'm extremely happy and excited to solve this. I'm going to divide both sides by 5. Divide by 5. Calculator is coming to my rescue and saying, well, 6, 5, 5. Oh, lots of 5s. Looks like a movie phone number from the States. 3, I'm doing terribly. 6, 5, 5. 3, 6, 5, 5. It's like it's doing both. 360 divided by 5. 131072. Okay, and that equals 2 to the n minus 1. So that's 2 to the power of something. Remember, we don't have a good method yet. Logs are coming our way soon. But for now, we're going to go 2 to the power of, well, let's go for like 15. 32,000. So let's go 19. Nope, we've overshot it. Let's go 17. That's it. So this is 2 to the 17. So 2 to the n minus 1. So 17 equals n minus 1. Whew. N equals 18. Let's take a breather. Okay, so we've got our breather. And now we're ready to work out this because we've got n, a, and r. So S, n, what did we say n was? 18. S18 equals a. 1 minus r to the n over 1 minus r equals, now this calculator was in our way, but there it was, equals let's close this and go. We've got a fraction, and we've got 5. 1 minus 2 to the power of 18 over 1 minus 5. What do we get? Oh, wow. That's a, I was hoping it wouldn't be a fraction. But it is a fraction. Fractions are our friends too. 1, 3, 1, 0, 7, 1, 5 over 4. I guess perhaps we could have pressed this S to D and written it as a fraction, as a decimal. Either way, right? Plugged into the formula, got an answer, good to go. Breather before our last question. Cool. Last one, example 3. Hope that is the last one. Yeah, it is. So geometric progression, I've kind of just pulled out the bits that are important from a more wordy paragraph. You're given a geometric progression. First term is 16, and the sum of the second and third terms is 12. Solve. Okay, I like to ask this. Ideas at this stage. Well, let's see. Geometric. We know that we might be using, let's just have them here at our disposal. Tn equals arn minus 1, and Sn equals, what is our formula again? A 1 minus r to the n over 1 minus r. As you use the formula, you know what it's like. It kind of slowly becomes, you'll get more used to it. Like the quadratic formula. You're first using it, what was it? Minus b, this or that. Then you're like, cool, minus b plus minus the square root of b squared minus 4ac everything over 2a. And you're like, oh, we use it all the time, right? Okay, so breather for myself. We're going to use these things. The first term is 16. Okay, so we know a equals 16. We know that t1 equals 16. In fact, we know that s1 must be 16 from that, because the first term is 16. The sum of the second and third terms is 12. Okay, so the sum of the second and the third terms is 12. Okay, well, let's use our Tn formula. So a r to the n minus 1. Now we already know that a is 16. So let's not make extra. It's 16 r to the n minus 1. Well, n is 2, so n minus 1 is just 1. Plus 16 r to the n minus 1. So n is 3, so n minus 1 is 2, equals 12. Quadratic equation. How do you solve a quadratic equation? I wonder if you've written down that you can use the quadratic formulas. I just referenced it. But I reckon let's rearrange. So we've got equals 0. That's definitely our starting point. So 16r squared plus 16r minus 12 equals 0. Just seems easier to write in that format. You know what? Let's divide this whole thing by 4. So that whole thing by 4. So that it looks a bit easier. So we've got 4r squared plus 4r minus 3 equals 0. Okay, that looks a bit easier to factorize. Equals 0. We're going to have r. We're definitely going to have 3 and 1. So I guess the question is, are we going to have 4, 1? Or are we going to have 1, 4? Or are we going to have 2, 2? I don't know which one. Do we need a 6 and a 2? I think that's going to work out quite nicely. We can have plus, minus. Minus 2r plus 6r gives us 4. Hey, we got it. That was nice. R equals minus 3 over 2. Or r equals 1 over 2. Okay, but what do we actually have to work out? Well, I didn't actually ask us. That was a great question. Well done, well done. But we've worked out everything we need. We've got A, we've got R. If we need to do something with N, we've got everything we worked out. We need... Yeah. breather time. Hit some of the exercise. Enjoy, right? Enjoy.